Find the Laplace transform of x of t equals u of t minus 2, convolved with t times u of t. Here, star represents the convolution operator. We have four options. A. E to the minus 2s over s squared times s minus 2. B. E to the minus 2 times s minus 2, all over s cubed. C. S times e to the minus 2s over s minus 2 squared. D. E to the minus 2s over s cubed. Convolution in time, multiplication in s. That is the only tool we need here. So x of s equals the Laplace of u of t minus 2 times the Laplace of t times u of t. Step 1. Apply the convolution property. X of s equals L of u of t minus 2 times L of t u of t. Step 2. Use the time shift property. L of u of t minus 2 equals e to the minus 2s over s. The exponential comes from the delay of 2. The 1 over s is the Laplace of u of t. Step 3. Use the standard Laplace pair. L of t times u of t equals 1 over s squared. This is the ramp function pair. Easy to remember. Step 4. Multiply the two results. X of s equals e to the minus 2s over s times 1 over s squared, giving e to the minus 2s over s cubed. Now let us eliminate the wrong options. Option A has e to the minus 2s over s squared times s minus 2. The s minus 2 in the denominator signals a frequency shift that comes from e to the 2t times u of t, not from u of t minus 2. Confusing a time shift with a frequency shift is the classic trap here. Option B has e to the minus 2 times s minus 2 in the exponent. That would require applying the s-domain shift instead of the time-domain shift. Wrong. Option C mixes s times e to the minus 2s in the numerator with s minus 2 squared in the denominator, a time shift exponential with a frequency shift denominator. Those cannot come from the same transform. Option C is out. The answer is option D, e to the minus 2s over s cubed. Let us do a quick sanity check. 2 poles at the origin means double integration in time, consistent with a ramp-type output, which is exactly what convolution with tu of t produces. The e to the minus 2s captures the delay of 2 seconds from u of t minus 2. Everything checks out.